Hi and Assalamualaikum. Me and my friends are from Group 11 of ZAE488 Non-Destructive Testing course. We're going to present about ultrasonic testing. I will begin this presentation with the introduction. First, let me introduce myself. My name is Nurul Huda binti Muhammad Tunisi with metric number 144388. Now, I'm gonna talk about theory. First, high frequency sound waves range between 0.5 and 50 MHz to conduct examinations and make measurements. Second, widely used in engineering application, which is flaw detection or evaluations, dimensional measurements, material characterizations, and other. And also used in medical field, which is sonography, therapeutic ultrasounds, and others. Third, there are two basic types of ultrasonic testing. First is reflected waves, which is pulse echo. Second, transmitted waves, which is through transmission. Each of the two types is used in certain applications, but pulse echo systems are more useful since they are required one-side access to the object being inspected. Okay, next I'm going to talk about basic principle of ultrasonic testing. First, a typical pulse echo ultrasonic testing inspection system consists of several functional units such as the pulsar or receiver, transducer, and display device. Second, a pulsar or receiver is an electronic device that can produce high voltage electrical pulses. Third, the transducer generates high frequency ultrasonic energy. Fourth, the sound energy is introduced and propagates through the materials in the form of waves. Fifth, the energy will be reflected back from the flow surface when there is a discontinuity such as crack in the wave path. Sixth, the reflected wave signal is transformed into an electrical signal by the transducer and is displayed on the screen. Seventh, the reflected signal strength is displayed versus time from signal generation to when an echo was received. Plus, signal travel time can be directly related to the distance that the signal traveled. That's all from me. Thank you.
Hi, my name is Nuranisa binti Abdul Jalil. Now I'm going to proceed the presentation on how to do the ultrasonic testing. So the question is, how does it work? Ultrasonic testing uses a piezoelectric transducer connected to a flaw detector, which is in its most basic form is a pulsar receiver and oscilloscope display. The transducer is passed over the object being inspected, which is typically coupled to the test object by gel, oil, or water. This coupling is required to efficiently transmit the sound energy from the transducer into the part. There are four common techniques of ultrasonic testing that can be performed in a few different ways, such as pulse echo, through transmission, normal and angle beam, and the last one is contact or immersion. The first ultrasonic testing technique is pulse echo, which is used to identify defects by measuring the time it takes amplitude signals to travel between the different points or surfaces in a material. This technique is primarily used when only one side of a material can be accessed. The second technique is through transmission, which employs two transducers, each placed on opposite sides of the material being tested. The third technique is normal and angle beam, which relates to the angle that the sound energy enters the test article. The last technique is contact or immersion. Contact ultrasound testing can be performed where only one side of a test specimen is reachable or where the parts to be tested are large, irregular in shape, or difficult to transport. In immersion testing, the component or material is submerged in water which act as a couplant in place of the gel used for contact ultrasound. So now I'm going to explain in detail of each technique. The first technique is pulse echo. A transducer emits an energy pulse while a second transducer listens for reflected energy or an echo. The existence of discontinuities and the surface of the test article cause reflection. The amount of reflected sound energy is plotted against time, giving the inspector information on the size and location of features that reflect the sound. In through transmission, the test specimen is equipped with two transducers, one of which serves as transmitter and the other as a receiver. Discontinuities in the sound path cause a partial or complete loss of sound transmissions, which is indicated by a reduction in the received signal amplitude as you can see in the diagram above. When the signal is weak, through transmission technique is effective for spotting discontinuities that aren't good reflectors. However, it does not give depth information.
In normal beam testing, the sound beam is introduced into the test article at 90 degrees of the surface. Meanwhile, in angle beam testing, the sound beam is introduced into the test article at some angle other than 90 degrees. The decision between normal and angle beam examination is usually made based on two factors, which are the orientation of the feature of interest where the sound should be directed to produce the most reflection from the feature of interest, and obstructions on the surface of the part that must be worked around. Lastly is contact or immersion testing. In contact testing, a couplant such as water, oil, or gel is applied between the transducer and the part. In immersion testing, the part and the transducer are immersed in water. This setup allows for more transducer movement while maintaining consistent coupling. Through immersion testing, an echo from the front surface of the part is seen in the signal, but the signal interpretation is the same for both techniques. Assalamualaikum and hi, my name is Nur Alia Natasha Johari and my metric number is 141181. Now let me explain what is data presentation. There are three data presentation which are A scan, B scan and C scan. The A scan presentation displays the amount of received ultrasonic energy as a function of time. In the A-scan presentation, relative discontinuity size can be estimated by comparing the signal amplitude obtained from an unknown reflector to that from a known reflector. Reflector depth can be determined by the position of the signal on the horizontal sweep. The B-scan presentations is a profile cross-sectional view of the test specimen. From the B-scan, the depth of the reflector and its approximate linear dimensions in the scan direction can be determined. It should be noted that a limitation to this display technique is that reflectors may be masked by larger reflectors near the surface. The C-scan presentation provides a plan-type view of the test specimen and discontinuities. C-scan presentations are produced with an automated data acquisition system such as in immersion scanning. Use of A-scan in conjunction with C-scan is necessary when depth determination is desired.
Hi, my name is Nuri Izzati binti Saifubari and I will present about the advantages and limitations of ultrasonic testing. We will begin with the advantages of ultrasonic testing. First is sensitive to both surface and subsurface discontinuities. Second, the depth of penetration for flow detection or measurement is superior to other methods. Third, only single-sided access is needed when pulse echo technique is used. Next, high accuracy in determining reflector position and estimating size and shape. Minimal part preparation is required. Electronic equipment provide instantaneous results. Then, Detailed image can be produced with automated system. Lastly, the advantages is has other uses such as thickness measurement in addition to flow detection. Next is limitation of ultrasonic testing. First, skill and training is more extensive than with other sound methods. Next, surface must be accessible to transmit ultrasound. Third, materials that are rough, irregular in shape, very small, exceptionally thin or non-homogeneous are difficult to inspect. Normally, requires a coupling medium to promote transfer of sound energy into test specimen. For linear defect oriented parallel to the sound beam may go undetected, and cast iron and other coarse-grained materials are difficult to inspect due to low sound transmission and high signal noise. 4 reference standards are required for both equipment calibration and characterization of flows. And I think that's all from me. Thank you.
In order to generate the high sensitivity results offered by ultrasonic testing, we must be trained and qualified to the relevant standards. So here are some of the training centers that can be chosen.